Welcome to lesson 3-12, where we're going to be distinguishing multiplication from division. We'll be looking at word problems and deciding whether or not we need to multiply or divide. Please turn to page 97 of your workbook and follow along with me as I model the first few problems. Directions for question number 1 says decide whether you need to multiply or divide and then solve. Number 1 says, a turtle crawls 3 yards in an hour. How far will it crawl in 2 hours? We could create a diagram to show our problem. We might create something like this, perhaps a T-chart. And on labeling the T-chart, on the top left-hand side would be the time in hours. And on the right-hand side of our T-chart could be the distance that the turtle crawls, and that's in yards. It says that the turtle crawls 3 yards in 1 hour, so we could label that in 1 hour the turtle will crawl 3 yards. Well, if that's true, then we should be able to make a pretty good prediction of how many yards the turtle can travel in 2 hours. Setting up a T-chart like this, we can actually try to find a rule or a multiple of how we go from 1 to 3, similar to what we do with fractions. You would multiply 1 times 3 to get 3, and so we would apply that rule to 2 hours. And 2 times 3 then would equal 6 yards. So within 2 hours, by multiplication, we could figure out that the turtle would travel 6 yards. And using the exact same tree, we can go to part 2 of this question where it says, how far will the turtle travel in a quarter of an hour? Well, we can continue to use this T-chart and put our quarter hour or our time over here and follow our pattern, our rule, which is times 3, and solve this to find our answer. So 1/4 times 3, we'd have to change that 3 into 3 over 1. Try to cross cancel 3 and 4, but there's nothing you can do. 1 and 1 are already simplified. So we multiply straight across, and we end up with 3 over 4, or 3/4. Question number 2. I have 2 tons of sand. I will move it with my wheelbarrow to a garden. My wheelbarrow only holds 1/10 of a ton. So I'm not going to be able to fit it all into one wheelbarrow trip. How many trips then will I have to make? So I have this mountain of sand. This mountain of sand is 2 tons. And I have this wheelbarrow. And my wheelbarrow will only hold 1/10 of a ton per trip. But I have 2 tons, so clearly I can't take it all in one trip. I'm going to have to divide my sand up into smaller amounts. In fact, I'm going to have to divide them into 1/10. So the question becomes, how many 1/10? How many times can I divide my sand up into 1/10? Or how many 1/10 can I get out of 2 tons of sand? Because that will tell me how many trips it's going to take me. Every trip, I'll be able to take a 1/10. So I take the first 1/10, that's 1 trip. Take another 1/10, that's 2 tenths now I've taken, but 2 trips. Take another trip, that would be 3 tenths that I've taken. Another trip is 4 tenths. My next trip would be my 5th, and I will have taken 5 tenths. My next trip would be my 6th, and I've taken 6 tenths. You can see from the pattern that in order to get to 1 ton, I'll have to make 10 trips. 7th trip will give me 7/10. The 8th trip will give me 8/10. My 9th trip will get me 9/10. And finally, on my 10th trip, I'll have a whole ton. It's going to take me 10 trips in order to get 1 ton of sand to my garden. But I have 2 tons of sand. So you can imagine that I will need to double the number of trips. You heard me say the key word divide. I had to divide my pile of sand up into smaller units so that I could actually drag them to my garden with my wheelbarrow. So we are going to be dividing. And we're going to be dividing our 2 tons into little piles of 1/10 of a ton. So we're going to divide 2 by 1/10. By doing this, we're actually going to multiply because we never divide. So we're going to take our 2, turn it into a fraction as 2/1. We're going to change our sign from division to multiplication, and we're going to invert our second factor from 1/10 to 10/1. Then we're going to solve by multiplying 2 times 10 to get 20 and 1 times 1 to get 1. And we could see that we were correct. By using a diagram and pictures, we could see that it was going to take 20 trips. By creating a math expression, a division problem, and converting it to a multiplication problem, we can see but mathematically speaking, it's still going to be 20 trips. Question number 3 says, I have 3 pounds of nuts. I want to use them to fill small bags with 1/4 pound each. How many bags then can I fill? I don't know about you, but I immediately start thinking about drawing pictures of nuts. So I'm going to just draw a pile of nuts. Call these nuts. A whole bunch of them here. There are 3 pounds of them, or 3 lbs. That's how you abbreviate pounds, lbs. I have 3 pounds of these nuts. I'm going to fill a bunch of little bags, and I can picture a bunch of little bags. I don't know how many I'll need, but I'll just make a few to start. Each of my bags holds 1/4 pound, 1/4 lbs, 1/4 lbs. 1/4 lbs. Every bag will hold 1/4 pound. Well, I can already start to envision that if I had just 3 bags, I would have 3/4 of a pound. To make this a little simpler, I'll add 1 more bag of 1/4 pound. And if I added all these bags up, I'd have 4/4, or 4/4, or I'd have 1 pound, 1 lbs. It would take 4 bags, in other words, to use 1 full pound of nuts if each bag held 1/4 of a pound. You could project that then, because if it takes 1 pound, and I'm going to create a T-chart to project this, if it takes 4 bags, or number of bags, to equal 1 pound, we can begin to look for a rule. And if we look for a rule going the right direction, which is from left to right, we're going from 4 to 1, we would be dividing. So let's look at this rule in reverse, from right to left. How would we find the rule going from right to left? How do you go from 1 to 4? By multiplying or dividing? You're going to have to multiply to go from 1 to 4, and you'll have to multiply by 4. So I have 3 pounds. 1 pound is 4 bags. 2 pounds, if we follow the rule, 1 times 4 equals 4, follow that rule, 2 times 4 equals 8, then I would have 8 bags. 3 pounds, follow the same rule, times 4 would get me 12 bags. So the question did ask, how many bags can she fill? Well, I can fill 12 with 3 pounds. But what I had to do here was take an enormous amount of nuts and cut them down into smaller bite-sized pieces of 1/4 pounds. In other words, I divided my pile of nuts into smaller, easier to handle sizes. So you've just seen me solve that problem with a diagram. Now you're going to watch me solve it with a math expression. We're going to take our numbers, our 3 pounds, and we know that we're going to be dividing 3 into quarter-pound bags. So we're going to take our whole number and create a fraction out of it by changing 3 to 3 over 1. Then we're going to take our entire division problem and create that into a multiplication problem by taking our 3 over 1, changing our sign to multiplication, and inverting the next factor, or writing the reciprocal of the next factor. And now we can multiply straight across, so we get 3 times 4 is 12, and 1 times 1 is 1, which equals 12, which is exactly what we said it was. We drew a picture to show that it was 12, and now we can show it with a mathematical equation. Now I would like you to continue to complete 3, 4, 5, and 6 on this page on your own, and then come back for the rest of the lesson. Pause the video now. We're on page 98 of your workbook. In the equations below, A and B are whole numbers that are greater than 1. So they could be 2, 3, or any other number greater than 1. And if we get to choose, we're going to choose the easiest numbers, which would be 2 and 3. They have to be bigger than 1, so 2 and 3 are the next easiest. N divided by D, these are different variables in A and B. So N divided by D is a fraction that is less than 1, which means that N over D has to be a proper fraction. It could be any proper fraction. Just it cannot be improper because it has to be less than 1. 1 over D, or 1 divided by D, is a unit fraction. Of course, it is a unit fraction because it only has 1 on top. So it's 1 unit of D. We don't know what D is, though. So we're going to use that information to answer questions about the equations below. Before you do that, please get acquainted with the proper labeling of our division problems. Typically, you'll see a division problem with a box. Here we have 4 divided by a third equals 12. You would typically write that like this. The answer is 12 on top. You may already know that the 1/3 is the divisor. It's the number we're using to divide with. It's called our divisor. The number in the box is called our dividend. And the answer to a division problem is called a quotient. So this is where they are with the box method, which we will not be using with fractions. And on fractions, we lie them down. So here you have the dividend, which is first, the divisor, which is what we're dividing by, and the answer, which is the quotient. So I'm going to talk about numbers 7 and 8 with you and then have you do them on your own. First of all, number 7 is a multiplication problem. They're taking A times B, which we know from the information up here that A and B are whole numbers that are greater than 1. And they're saying that A times B equals C. So will C be greater than or less than A? In other words, if you're multiplying two whole numbers that are greater than 1, and you can replace these with numbers of your own. And that's what you probably would want to do here, is take A and assign a value to it. Just make the number larger than 1. It has to be 2 or larger, and they should be whole numbers. And if you make B the same, you could even make them the same number. They didn't say they had to be different. If you replace these with real numbers that we're allowed to replace them with, and then solve, you should be able to answer the question, is the answer greater than or less than A? And then you should be able to explain why that's true. For number 8, we're taking A, which is a number greater than 1, but a whole number. We're going to multiply it by a fraction, N over D, which is a fraction that's less than 1. It could be any fraction as long as it's proper. It can't be improper. It says it's less than 1 up here. Has to be less than 1, and that means that it's proper. So if you're multiplying a whole number times a proper fraction, will the answer be less than or greater than A? These are just making predictions, which we've already done. With questions 9 and 10, use the same strategies we used above. The rules are the same for the letters that you see. If you want to assign values to them and solve them to help you figure it out, that's perfectly okay. Number 11 and 12, do not calculate these. You should be able to tell me which answer is going to be larger without calculating.